Let's jump right into this explainer and tackle a mystery that honestly haunts just about every IT admin out there. Why do critical emails suddenly bounce? Today, we're decoding authentication non-delivery reports, or NDRs, right inside Microsoft 365.
Look, we've all been there, right? Staring blankly at some completely cryptic bounce message. You're left scratching your head, wondering, is my domain reputation tanking or did somebody mess up the authentication? It's incredibly frustrating when an important message just completely fails to deliver and all you've got to go on is a giant wall of numbers and technical jargon.
So, to get to the bottom of this, we're going to play IT detective. We'll look at the anatomy of an NDR, decode those crazy authentication error codes, figure out exactly why DMARC fails, run through the M365 diagnostic tools, and finally, fix your email foundation. All right, part 1, anatomy of an NDR, understanding the clues. Our very first step is just understanding what actually happens under the hood when a message looks a bit suspicious or totally fails its authentication checks. So check out the stark contrast between Microsoft's delivery pools. Whenever you send an outbound message through Exchange Online, it gets scanned. If your email starts exhibiting some unusual or spammy activity, Exchange Online actually diverts it away from their standard, high-reputation servers and drops it straight into the high-risk delivery pool. Why? Well, Microsoft has to protect their primary servers from ending up on global block lists. But for you, it means a drastically lower sender reputation and, honestly, a massive chance your critical emails are heading straight to the recipient's junk folder. When that delivery fails, the resulting non-delivery report, the NDR, is basically our crime scene report. Now, the modern NDRs in 365 have been completely redesigned, and they are actually super helpful. You get a plain language cause of failure and this brilliant fix-it owner indicator that tells you exactly who needs to step up and take action, sender, Microsoft, or recipient. But the real gold mine? That's way down at the bottom in the More Info for Email Admin section. That's where we find the technical clues, the server hops, and the raw status codes we literally need to crack the case. Moving right along to Section 2, decoding authentication error codes, translating machine speak. Let's look at the core authentication protocols and see how they trigger those really intimidating error codes when something goes wrong. First up, we've got SPF, or Sender Policy Framework. The easiest way to think about SPF is like a VIP guest list at the door of a club. It simply verifies that the server IP address trying to send the email is explicitly authorized to do so for your domain. If that IP isn't on the DNS record guest list, boom! The email raises a massive red flag. Next, let's look at DKIM, which stands for Domain Keys Identified Mail. If SPF is the guest list, DKIM is like a digital tamper-evident seal on the envelope itself. It adds a cryptographic signature right to your message, so when the receiving server gets the email, it checks the public key in your DNS to verify that exact signature. If everything matches up perfectly, the server knows for a fact the message wasn't intercepted or messed with while it was in transit. And finally, we have DMARC. This is the big one that ties the whole shebang together. DMARC takes the results from your SPF and DKIM checks and hands very strict, explicit instructions to the receiving server. It essentially says, hey, if this email fails SPF or DKIM, here's exactly what I want you to do with it. You can tell it to do nothing, quarantine it, or just reject it outright. Okay, so what actually happens when these protocols break down? Well, you get hit with error codes. For instance, if you're staring at a 4.7.26 error, that instantly tells you an IPv6 message failed basic SPF or DKIM validation. And that happens because IPv6 messages strictly require it. There's no way around it. Or maybe you see a 5.7.367 error. That means not permitted to relay, which happens all the time when emails get forwarded through non-Microsoft gateways, completely breaking the SPF or DKIM authentication along the way. But the code that truly haunts administrators? That would be 5.7.509. This error flat out blocks your delivery. It means access denied, sending domain does not pass DMARC verification, and has a DMARC policy of reject. When you see this, it's not the receiving server being a jerk, it's actually just following your own domain's strict security instructions to drop the message because it failed those checks. Which perfectly segues into Section 3, why does DMARC fail? Finding the friction points. The crucial next step is figuring out exactly why your DMARC verification is failing in the first place and triggering those 509 bounces. So who are the usual suspects here?
It almost always boils down to a handful of specific misconfigurations. Sometimes it's just a missing or syntactically incorrect DNS record. Easy fix. But a massive friction point, and one that's honestly pretty tricky to spot, is an alignment issue. This happens when the hidden envelope sender address, known as the P1 domain, doesn't perfectly match the visible from address, the P2 domain, that the user actually sees. If those don't align, DMARC fails. You might also run into automated forwarding rules that just mangle your message headers in transit, breaking your DKIM signatures entirely.
So, how on earth do we figure out which culprit is to blame? Let's go to Section 4, using M365 diagnostic tools, the interrogation room. Instead of just guessing, we can literally interrogate the system directly.
Microsoft actually provides some incredible built-in tools to do the heavy lifting for us here. It's super simple. You just copy the exact NDR error code from your bounce back, jump over to the Microsoft 365 Admin Center, and launch the Run Non-Delivery Report Diagnostics tool. You paste your code in there, hit Run Tests, and let Microsoft's backend instantly reveal the exact security gap causing the block. I mean, it literally saves you hours of manual log hunting.
And that brings us to Section 5, Fixing Your Email Foundation Case Closed. Because once that diagnostic tool identifies the gap, it's time to resolve the issue and officially close the case.
Your resolution workflow needs to be highly systematic. They'll want to start by reviewing the specific message headers, specifically hunt down the authentication results line to see exactly where SPF or DKIM tripped up. Next up, guarantee that your P1 and P2 domains perfectly align so your DMARC can actually pass. From there, log into your DNS host to fix up any malformed TXT records. And yeah, then you just grab a coffee while you wait for DNS replication to kick in, right? Finally, just keep a really close eye on your bulk sending limits so your tenant doesn't get penalized and thrown right back into that high-risk delivery pool we talked about earlier.
So the next time you see a bounce back, don't just delete it, and definitely don't just blame the recipient's firewall. Ask yourself, is your own email authentication foundation truly secure? Are your SPF, DKIM, and DMARC configurations actually optimized to keep your domain out of the high-risk pool? Review those NDRs, run the Microsoft diagnostics, and lock down your email flow. Thanks so much for joining me for this explainer. Now get out there and solve those mysteries.